Yeah.
And so what? In fact, the three of us are here. Nick, that's me, Nick, PM director. I'm the first guy on your on the slide. Des, who's our CEO, and Bill, who's our COO. We're all three of us here.
Yeah.
And for this second show, we're basically trying to identify the opportunities in 5G, which is of particular interest because 5G is moving more and more towards the wireless applications and the wireless devices, in which the capability, the special capability of the TransSiP product, TransSiP PI product, is becoming more and more important. But first of all, I need to make a disclaimer to point out that actually, though we are going to be as straight and honest as we can, we can't be absolutely certain that the forecast that we make will be accurate. So at your risk, be it almost. Okay, and what we're going to be doing over the next few weeks is having a look at 4 areas of. We will be looking at the semiconductor vendors in the next webinar, and there I've got the semi guys are tapping into the power of TransSiP PI for noise reduction on chips. In industrial applications, TransSiP PI is acting a bit like a painkiller. And for the future, we're looking towards developing the TransSiP PI second level, which we'll be introducing to you over the next few weeks. But for the moment, we're going to stick with 5G radio because of the interest and the application. We are accessing markets through a deal that we've sent, or in the process of setting up with a major Japanese semiconductors manufacturer, which gives us access to a whole new range of marketplaces, which is really very exciting for us. So it means through them, we can tap into Sony and Microsoft and Amazon and Foxconn and many others.
Oh, I would like to address one point from this.
Yes, please do.
Yeah, there's a very special thing about this partnership. There are many semiconductor vendors in the market. The key point is we are not competing with any one of them. In that $600 billion semiconductor market, our technology is a complement to them, enabling all the billions of devices they make to run faster, more accurately, and consume less energy. So this is how we position TransSiP in the market space. So that is a very good thing. And one more thing is this new partner not only enable us to gain access to all those, family known brand name, but also help us to access the Japanese market, which is very hard for any other vendor to do. So that is very special about this partnership.
Fantastic. Thanks, Des. Yes, we'll be having a look at that towards the end of the presentation anyway as well. Let's have a brief look at what's been going with APEC. And with APEC, we had something like 60 contacts. And many of those are now turning into action. So companies like Corvair and Texas Instruments and other devices.
Nick, sorry, I'll just jump in. And we're assuming that our audience knows what APEC is.
Yeah, this is true. Okay, APEC basically APEC is the show in America for basically for power devices, and we see ourselves as becoming the important factor in the power supply world. So through APEC, we've got into the contact with companies in terms of being power supply, or more specifically, providing a very low noise power source.
Yeah.
But
yeah, implementing what we're calling a TransSiP PI. PI stands for Power Integrity Solutions. And Desmond was out in Orlando in February and knocked him dead. And one of and we're going to understand why that happened and what's behind it as we go forward through this presentation. But some of the key players that have emerged from those conversations are shown on this slide. We don't usually talk about things before there's a signature and so forth in place. However, we do have permission to reference what's going on here, and as we can see, it's pretty big time.
Yeah, it's pretty big time. I also want to add one note about what we achieved this year at the APEC show. we've been there since many years. Especially this year, all the vendors are showing their very high power solution, 100 watt, 100 volt, 1000 volt. Then how we can, position ourselves in that very high power markets, and we find we do, because to have a very good control, high efficiency, high power system, they also need signal integrity, means very good signals. So that related to the noise. So this is how we our filter come into play to help them.
One thing that we didn't mention, and probably deliberately so, because these conversations are still in the early stage, but what the synonym for high power is autonomous vehicles, fully BEVs, fully battery electric vehicles. So in addition to the significant power savings, and we'll see this later, that our power integrity solutions enable in DC to DC conversion, that is when you go from the battery to what's going on inside the gizmo.
Right.
There is, we're looking at almost a 40% improvement in that conversion efficiency. And if you multiply that times the billions of devices which are currently using resources to generate lithium-ion batteries and recharge them and so forth and so on, the numbers get to be extremely interesting. If we then start to add that access to the autonomous vehicle market, it really gets to be something. But this is all.
Oh, Bill, we lost you.
Just disappeared. Again, in fact, we were at the show showing this evaluation board, handing out the evaluation board where people can actually try out the Symphony and the Harmony products. Here's an example of the evaluation board. In fact, the Symphony chip itself is just that tiny little black square in the middle there.
Very, very tiny. Our solution is just like the little black dot, just the size, the grain of a rice is very small, the solution. But it's very powerful.
And in fact, we have several people who have already used and have given us some very, very positive feedback. And Raycon, that's a very important clock manufacturer. We'll be talking about them in a bit later. The CTO of the Matrix company who produced this, the GPS watch, and Mr. Peter Mayer, of course, from Tahia Investments.
Nick, I'm going to ask you to cycle back one slide, if you don't mind.
Yeah, sure.
Okay, gentlemen, to our audience, I'm Bill Burr. I'm head of operations here at TransSiP, and I have a manufacturing background, which means hardware, which is how Des and I got together back in 2014. The reason I asked Nick to cycle back to this slide is that if you look at the illustration on the left, you're seeing quite a bit of hardware around that little black dot in the middle. And what this means is that Des in our lab in Irvine, California, is working with analytical techniques which span the range of the whole microwave spectrum. And this is critically important to the later discussion about 5G. And we talk about microwaves, and then microwaves are extending anywhere from about 1 meter wavelength down to 1 millimeter. So when we get to the point where we're looking at the thousands and thousands of microcells, which are going to be operating at very high frequencies, that is millimeter wave frequencies in the 5G network, we're going to be ready.
Good point. Yeah, that's good point. I would like to make a little bit more information about the way we make our EVB. You see those very special microwave connector. Why is that? This enable our customer to look at the noise, the spectrum of the noise from DC all the way to microwave range. This is a very broad spectrum of noise. They can evaluate how much noise our technology has been taken out on the power line. I guess what we are possibly the first one. I don't know if we are the only one yet, but from our knowledge, possibly we are still the only one can do that.
Nick, if we cycle up 2 slides, then we've got a good lead in to what we're talking about. Des, you want to take it away here?
Yeah, okay, well, let me start this one. I mean, the essence of the technology, the core of our technology is the SNJ, the signal noise jitter, which is basically looking at the whole question of phase jitter or phase noise as the next level of integration. And we've identified that, and we've come up with a technology that eliminates the SNJ, which has the impact of reducing noise, that band of noise, substantially. And that becomes so important when you're operating at the sort of frequencies that we're looking at for wireless, for 5G and the like.
Yeah, and I would like to let you know, we are the first mover on that, and no known competitors on this discovery. So we not only discovered that, so we successfully capitalize on this technology and make this into a chip, and then complement all the billions of devices other vendor making.
I just want to spend a couple of just a couple of more minutes on this slide. You know, there's lots of colors there, lots of stuff going on. Now, we're all of us used to seeing the kind of displays that we used to see in Star Trek, particularly the original black and white version, where you have oscilloscopes with the sine waves and all the sound effects, etc. And those were representing electrical signals. Now, what we're looking at here is a completely new way and a new dimension on signal noise analysis. This is real-time spectral. Thank you, Des. I always have a tough time pronouncing that. But what we're doing is as opposed to looking at the frequency component of noise, what we're looking at is the random variability of noise events over time, and the colors represent the relative density of those events. And what we're seeing here is something that you cannot see using conventional analytical methodologies. And what Nick is showing on the left is that that bulge there, that yellow and green bulge. Basically, we're assigning colors to the probability of events within certain bandwidths of time. So as these events change, or as these events are eliminated, that is, the time variability starts to disappear, those colors get to be less. And that's why the bulge on the left turns into a much more uniform rainbow type of presentation on the right.
Mm-hmm.
Thanks, Bill. Now I understand it.
Okay, next slide, please.
Moving on to watches. That we've done watches. Okay, so let's get back down to 5G, and why 5G is so interesting, because it's quite clear that a lot of these problems have to do with the core, the hardware of 5G, in terms of what is slowing things down, what is not allowing 5G to do what it should be doing. Is this clock quality, the actual...
Hey, Nick, you go.
Yeah, sure.
Go back. Go back one, man. You're going too fast.
Yeah.
These are the numbers associated with the headline that we just saw and what Nick is talking about. Rather than the advertised data speeds about between 1 gigabit to 10 gigabits per second, actual field experience is showing that we're down around 140 megabits per second. So we are about 1/10 of where we wanted to be at the bottom line.
Yeah, that is a big problem.
So the question is, what's going on here? And obviously 5G is a massive a type of discussion. You know, we're talking about not only software issues, we're talking about backhaul, mid-haul, last mile, the cellular geometries and all the rest of it. But something that jumps right out at all of us is that any 5G device And when I say device, I mean not only smartphone, the receivers, et cetera, but also the mini cell stations. They've all got to be operating at very high frequencies. And at this point, the quality of the clock signal becomes absolutely critical, because if you've got noise in the clock, and your clock is not going tick, 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 but it's going like that, you've got a real problem in high-speed digital systems. Sorry, Nick, take it away.
No, that's absolutely fine. Because and the interesting thing is here is that if we look at the work that's been done in developing and designing the 3G system, 5G systems, that they're relying on an understanding, if you like, of a noise level, which is at the bottom, the ideal scenario. When you start putting into a real world and putting chips into it, you get noise on the power signal that's much greater, as in the upper, the black line on this one. And even that black line is in some ways an understatement of what the problem is.
Yeah, I would like to tell one thing.
Yes, please.
How we discover that is actually we have a partner. So if you follow our updates, you already know the name called Raycon. So Raycon is one of the world-renowned oscillator company. They are offering a must-have component in all the communication system, not only 5G, not only cellular, but also satellite. So they told us one problem in the real world is all the power supply noise in all the communication system has this common problem. Because whatever new technology or new communication we are defining, okay, even moving beyond 5G, talking about 6G, all the lab are working under an ideal scenario, just like the noise of the purple, the blue thing we are showing you. So all the technology are based on that ideal scenario because they are using a lab grade equipment, making their prototype, making their chip. But Raycon told us, from many years of their field support experience, is the noise is not something close to the lab setting. No way. So that is the bottleneck of blocking, the real world performance, just like the 5G speed we spoke about. And so the black curve on the top is showing you what is the actual noise level in nowadays in cell phone, in a space station look like compared to the bottom one, inside lab setting. There is a huge gap in that. Okay, that is a technological gap over there. Sorry, Bill. Next, move on.
No, absolutely, because basically what we're saying is that the power source for a smartphone or the base station or the like produces this extremely noise-rich power. Okay, and we're putting harmony in, which enables us to filter it down to a level where, for example, the crystal oscillator can operate in a much better way, much more effective way. So we're looking at a solution here, and for this, Bill, I have to apologize, I didn't include the line, but we'll come back to that in a minute. By introducing the harmony, and you'll see that, remember that harmony, we were looking at the evaluation boards. We produce a harmony which is filtering both the power line and the signal line into the clock, which produces a much simpler, much quieter, lower phase noise. Des, do you want to lead us through this a bit?
Yes. So also, now we have a solution. We work with a wireless lab on this topology. So that is also mean is presenting a potential to work with all the key 5G radio vendor. Why is that? Now the limitation is on the radio design for the signal integrity, the clock quality. That means we are predicting for the next few years hundreds of billions of 5G devices, not even talk about transitioning from 4G. We are talking about all the 5G device has been on the market. At some point in time, they all need to be replaced because of this problem. Because no way if they don't change their hardware, no way they are able to increase the speed of the 5G. Because that is a fundamental problem they haven't solved yet. So, we are trying to make TransSiP to play a pivotal role in the radio design in moving forward. This is the opportunity we are seeing now on the 5G.
And it's because this is at the evaluation board level, but you can see the difference that TransSiP is making from this noisy signal power base beforehand down to this much smoother layer subsequently.
Hey, Nick, I would like to jump to the backup slide to show our audience the number. Because looking at the curve, hardly to understand the thing if you don't quantify it. So we have a slide to show the phase noise, the jitter, the number, the table.
Yeah.
If you scroll down a little bit, I would like to jump to that table. This one, yeah. Because one of the key metrics to talk about the quality of the clock is a term called RMS jitter or phase noise. So the first row is the ideal value of about 17 femtosecond. Okay, so under the real world setting of the power supply noise, it jumped up to 63 femtosecond, so like 4 or 5 times more. Okay, and then without filter in place, even under the real world condition, that parameters reduce to about 19 femtosecond, already close to the ideal lab setting. So remember that the ideal lab setting is a very complex setting, but our little device can already make it close to that ideal condition. That is insane. That is insane technology. Because the equipment they use in the lab costs at least 250,000. Okay, but the real world power supply is just a few dollar thing. And if we translate that improvement into signal to noise ratio, it's talking about at least 10 dB improvement in the signal quality. And then imagine that 10 dB improvement, how that will significantly impact on the data rate in real world.
Because let's remember that 10 decibels is not just, it's not just 10 units, it's a factor of 10, isn't it, we're talking about?
Yeah, that is what we are working on now, and we work with a wireless lab. They are testing on a platform, on a 5G platform made by one of the world top 3 vendor. So we are still working on it. The result, we are not ready to release this, to the public domain, but yeah, we are on the way to release more information on what we are going to find.
Okay, let's just whiz back to the products here. Let's go to that one here. Okay, so the interesting is that this application, this reduction of noise, well, the problem of noise is going to occur across the board in many applications of devices. And as devices get faster and lower power, and the noise becomes an even more and more acute situation. So if you like, we are taking a role of providing the manufacturer, the product manufacturer, to realize their functionality and so forth against a much quieter background, which enables basically or facilitates the products that they're producing. Des, do you want to expand on that?
Yeah. All right. So the whole electronics market and semiconductor market is multiple trillion. So we are, we don't want to float that, that type of number. So we already assessed carefully how big the market the TransSiP PI technology can get access to. Just right now, even on the current product, this market space we are playing is already represent a more than a 5 billion market. So when we are able to expand our market reach by that four strategic initiative, we are foreseeing a servable market of more than 100 billion.
Fantastic. Okay.
Yeah. So I guess Nick, I guess
Sorry,
yeah. Let you finish that. I guess we need to give some time to our audience for their questions.
Oh, sure, yeah. So basically, we're taking this what might be called the Dolby or Gore-Tex strategy. I mean, we are in the same way as Dolby is to sound and Gore-Tex is to leisure wear, if you like. We are becoming a sort of an intrinsic enabler of all the capabilities that our customers, which are the semiconductor manufacturers, which are the 5G system manufacturers and so forth, we're enabling their products. So we become built in, we become a long-term, if you like, investment for, and that if you like, the noise filter technology, as the voltage is reducing, as the complexity is increasing, that filtering becomes more and more important. And our new step forward in filtering technology will be the back of all these new developments.
Yeah, in order to back this technology, that's why also crucial on our business development to find more partner, so that this technology will not only be available from TransSiP, but also available from other vendor, and that will really truly make this technology to become timeless.
Sure. Okay, let's we have lots more we can talk about, lots more.
Yeah.
But let's ask some questions and see what's of particular interest.
Maybe first of all, because we before the meeting, we have a guest, William. William has posed a question to us. William asked about licensing. Maybe so I would like to explain this a little bit. So our business model, is not licensing at all. We are manufacturing. So we make the chip and then sell it. In terms of the partnership with that Japanese customer, it's also the same. We will take care of the manufacturing of the chip for them, basically. Yeah, that is a good business, much good business rather than licensing, we would say. So I
would say perhaps another way to answer this question is that this is an ongoing conversation within the executive committee of TransSiP, and you're looking at them at the three of us. I mean, that may sound like a big deal, but the three of us have over 150 years experience in the electronics industry. I was very deeply involved in licensing some of the fundamental technologies that built the printed circuit industry. So this is not a this is not a closed subject whatsoever. One of the things that's perhaps not self-evident in these presentations, because it really is not currently the focus of an investment program, but TransSiP is fundamentally a technology company. And we, in addition to this particular business line, which is the TransSiP PI, there are other patented technologies which contribute to the whole problem and the whole challenge of power integrity and power management going forward. And those opportunities have yet to be exploited. So we definitely do have a technology outlook on what we're doing, and we'll see what the future holds. As Desmond pointed out, the initial focus is necessarily on manufacturing, on getting the wheel turning, getting the wheel turning at a level in which this technology becomes a reference point for the industry. Because what we really have here is that this timeless technology is the third dimension, in addition to two common denominators, which may have come out of this presentation. One is that
Really vanished.
Oh, Bill, we know your collection is back.
Okay, am I back?
Yeah, you are back.
Okay. Okay, fine. Well, it was starting to get long. I think but the key point is that there's a lot going on here. In addition to timeless technology, we are enabling significant opportunities in power management, in conversion efficiency, energy savings, increased autonomy for portable devices, and the noise reduction capabilities of this technology have been the subject of this webinar. So thanks for your patience, and we're looking forward to
I think William want to you have some comment, William. Yep. You have to unmute your mic.
Hi.
Hi.
How to tell you, I am a former professional, now retired, so I can answer such questions. Are you considering the selling of your IPs or the selling of the cells of your design for different technologies, for example, to the same analogic devices for the 24-bit converters, or for example, some companies that are producing the special chips for the power. The sale of the IP as is, do you consider all these possibilities?
Our focus on manufacturing, William, at this point is leaving that for the moment off the table. The fact that we're dealing with a completely new dimension in measurement of noise phenomena means that this is a highly educational cell. What our primary focus is with regard specifically to your question, when you said manufacturers, for example, of 24-bit ADC, et cetera, our objective there would be to become a fundamental element in their reference designs.
Mm-hmm. Especially when we move into the TransSiP PI 2.0, we would say the licensing based on the 2.0 will be closer on the table. Will enable many of them to integrate into their SoC, system on packaged, or silicon system on silicons, especially on the heterogeneous integration. That is also the goal of why we developed the TransSiP PI 2.0.
You see, I have pretty large past experience in development on 24-bit ADC, in development of some GPS circuitry. And one thing, when your chip, or even without the package list, will stay on the same board. Another one, it will be just a cell that you will sell to somebody. You will sell as IP for different technologies. Because in this situation, for example, if I wasn't standing in front of this task, I definitely would prefer to have it as a standard cell, to put it inside my chip, and not to do the phase noise reduction for the whole board, where it can be a consumption of tens of watts, but only for my chip. Because in this situation, it makes sense. All the rest, if there are digital chips, whatever, I do not care. And from my point of view, it could be more interesting if you will sell either IP or the ready-made cells for different technologies. I don't know, for 90 nanometers or something else, what is used right now for analog design.
Well, that's very interesting that you should be mentioning this, because we have had conversations about this in the past. The idea of this technology as a standard building block, or we're using the term standard cell within the semiconductor environment, is certainly intriguing. At the current state of the technology, the geometries, and of course here we're getting into areas which are highly proprietary, but I think suffice to say that it does not, the technology at its current level lends itself much more readily to application as a standalone device than as a standard cell within a semiconductor manufacturing concept.
Yeah. So this technology we see, it still take years to evolve into the building process, because now today we are using a very specialized process. So from our point of view is quite different to what the majority of that they are doing today. On the manufacturing technology, that will need to be addressed. If we need to turn it into a standard cell for the chip designer to use. Yeah, from our point of view at this moment.
Okay, thank you.
You're welcome.
Yeah, we are welcome. And Jeremy or Joseph, yeah, welcome to spit out.
What was interesting, I was living in Irvine a few years ago.
Yeah.
You're living in Irvine, where you, there you go.
I see.
Where are you now? It looks like very nice with palm trees or something out the window.
Guys, we left California for Florida.
Ah, Florida. Staying warm.
We were living in Laguna Hills for 5 years after that.
Right.
Great.
Good.
Yeah.
Well, we'll repeat the call. Desmond invited our other guests to spin up, as it were. I mean, talk about the technical jargon, but are there any further questions, fellas?
Can you all hear me?
Yeah.
Yeah, fine.
Hey, it's Jeremy. Yeah, I know I posted something in the question area, but I was just saying it seems like with what you guys are trying to do and the fact that you guys are, I know you have revenue. I'm not sure if you guys are profitable yet, but I just don't understand why there are a whole lot more people here, because you make everybody better. So I wish I could help a little bit more. I'm just a individual investor, but if you're ever coming to Washington, D.C. and want to play golf, let me know.
All right.
Love it.
Jeremy, thank you.
All right. So
yeah, just I'm sorry. Go ahead, Des.
Do you want me maybe I can jump in, because other than my role on CEO, I also acting on the role of the CFO. So in terms of sales number, I can give you a big picture. Are we profitable? Yes, certainly. If you look at our spreadsheet, we are already capable to generate positive cash flows in 2019. And in terms of hard cash put into by our founder, we already put more than $700,000 into this business, and so far, that all has been paid back to our founders. Out of that more than $1 million sales we already made in history, so that from this number, so you can understand from investor standpoint how much cash that can be generated from a business will tell what actually the business is doing. So that's why I would like to address this point. Yeah. So I would just say we are literally like a very high profit margin business, I would say.
Thank you. You've got to be quiet. You've got to be quiet, Des.
Yeah,
we have to
we have to use the term very precisely, we don't want to get into trouble, understand.
Well, this is great because we have a chance to talk to people who've been around the block and
Right.
obviously have business experience. For the moment, and this would dovetail with the question that we heard earlier from William. I mean, if we were able to move to a completely IP business model, then there's no sunk capital and it's just recurring income. What we are doing, I think the easiest way and fastest way to describe our business model for the moment is we're basically a fabless company. So we've got the IP. We're doing all the high, the high end stuff, the high margin stuff in terms of development and so forth. But I'm in charge of our supply chain, and we've got world-class manufacturing partners. I lived in Asia for a long time, and so have been dealing with using my personal contacts there and so forth and so on. So we're in a position to scale very rapidly. As far as the question is, the comment, we're going to be doing, or we can do a lot for the world. I mean, world and with a capital W. We're very, very excited about the sustainability aspects of this, the impact that it could have on the whole energy budget associated with the billions of devices that there are. I don't want to get ahead of myself, but I'm very excited about this.
Yeah.
But it's an educational cell. What the Nick's slide is showing, noise filter technology has been stuck in a 40-year-old paradigm. So people don't realize that. I mean, this is, they don't realize that this problem is it's latent and it's about to nail them. What we saw earlier, the difference between 1 gigabit per second and 134 megabits per second in the 5G world, that's not because Nokia or Viacom or whoever is not building their cell towers right. A lot of that has to do with the fact that these problems now are starting to show up as on-chip voltages decrease and operating frequencies increase. Mm-hmm. So what I think then I'll sit down and shut up. But I think what we're looking at here is most definitely a hockey stick type of experience for our company and our investors. It's going to be slow.
Yeah,
it's going to be slow for a while as this thing gains momentum. But once it clicks, look out.
And also, I would like to talk about the capital expenses on the R&D. Our filter technology is very different than conventional semiconductor business because when it's done, the technology basically is done. The high capital investment, we already have done that already. So for the rest of the future, it's just a proliferation from that basic R&D we already achieved. So
it's
we
marketing
do not,
and education.
Is more on marketing things,
marketing and education,
or just to diversify our product portfolio. So that's mean we will relatively lower risk. So this is how we manage our risk. So that means this is relatively low risk than conventional semiconductor business, because if because semiconductor business have a very typical phenomenon is that people need to pump in millions, tens of $millions before they can generate revenue. So from our history, our investor already understand we are not. We already start generating business, make profitable for all the money we already pump in, and now most of them already returned to our founders already. So that is the very unique thing about this business. Very, I would say, and also we are the first and the only one semiconductor startup break the barrier for our investors. So every investor like you can join us. rather than use because this market space typically only for the venture capitalists. That is. So this is how we see our value. We are proud of that. So that's why our technology is analogous to Adobe or Gore-Tex. So one, we have invested in it, so you take, basically it's done. The most basic fundamental R&D already done. So we just need to take it forward to, to enhance it, to expand the market. This is what we are going to do.
Could I ask another question?
Sure, yeah.
Sorry, so 5G seems to be, I'm sorry, there's an echo on my, okay, there we go. 5G is just one part of what you want to do, if I understand it. And also, just to say that quickly, 5G, we won't get to 5G requires higher frequency, which generates more noise. And we're not going to get to 5G unless we reduce the noise, and that's what you do. But is 5G the biggest part of what you're going to do, or do you have other aspects where this noise reduction technology can generate the revenues?
Well, I'll take that, if I may. And thank you. That's a really insightful question. We've chosen to focus on 5G in this particular webinar. We did one a couple of weeks ago. We're going to be doing more of them, and they're going to be looking at different aspects of the opportunity. But I think one way to answer that question right now with the presentation that we have in front of us, and do it reasonably quickly, is that there are two common denominators which distinguish this technology. One of them is the noise reduction, which has been the primary focus of this presentation, and you hit the nail on the head, Jerry, with what you just said with regard to higher frequency, and therefore you're more sensitive to noise, etc. So noise reduction, I guess, would that aspect of the offering is the primary theme here. Noise, the ability to filter out background noise opens up possibilities in applications which are far removed from 5G. For example, if we take your heart rate monitor, your portable medical devices, they are dealing with very faint signals, which are the result of the lasers or whatever is being used to look inside your circulation system. So there's one example of a very faint signal. Another one that Des is currently working on. There's a fair amount of classified information there, but it's a perimeter defense system. So this type of technology enables you to filter out the sound of the vehicle driving along the perimeter and be able to hear the bad guys who are walking around outside. So right there, we've got two applications. And there are many, many more which are quite different from 5G, and of course the military one is not what we would consider to be high volume, etc. But we are very, very interested in and looking very hard at the whole wearable medical opportunity. Yeah. So that's one. The second common denominator is this whole idea of increased autonomy. And how does that work? Well, in something like a conventional smartphone like this, they're using to convert the battery voltage to the level of voltage that's necessary to make the thing run. They use what's called DC to DC conversion. Now, the 40-year-old paradigm we keep talking about means that you are using a linear regulator. Is using God's own amount of power in the form of heat. It's very quiet, but it's also very, very inefficient. what our technology does, because we deal with the noise on the noise, is that these devices now can rely entirely on digital power supplies, the so-called switch mode power supplies. And basically they're transistors which you're turning on and off, and they are forming the voltage that's necessary. Now, since you've got things turning on and off, it's like you turn the light switch on, you got light, turn it off, turn it on again, you've got light to light your room. And you're obviously being very noisy when you do that. Well, our technology removes, it basically makes that noise, it drops that noise to the point where a digital power supply, a switch mode power supply, can be used for the most sensitive applications. And this is where we got started, because Des was doing consulting work for a GPS manufacturer. He found that, you know, things were just not quite working, and looking at the thing and not sleeping and working all night and so on. And then there's a bang, there's the wow moment. Maybe there's something else going on. And GPS is the most sensitive type of system that's currently used in commercial electronics today. And our technology enables the use of switch mode power supplies to power GPS. So that means that the potential for savings in terms of the entire battery food chain can be significant if you no longer have to charge batteries, because you can run off body heat, which we make possible to do, et cetera, et cetera, et cetera. So that's that's the medium-sized answer to your question. Is it just 5G? The answer is no. There's lots of stuff based on noise reduction and increased autonomy.
Yeah. So what we are doing is try to find where would be the big opportunity for us to grow our business. So 5G is just one of the initiatives. The second initiative, like we have to partner with different semiconductor vendor. Now we successfully engage with one of them, you know, from Japan. That's good. We are also working with others. One of them is one of the world top 3 analog supplier. So we are working on with them as well. More than that, like we are our device also being evaluated by one of the world's well-known test and measurement equipment maker in one of their leading product line as well. Yeah, we have different initiative on the business development side. Industrial-wise, like Bill Watt have just mentioned, yeah, we some national security system, we are in there. That is good, because once we get in, the production of that will take more than 10 years. You know, the life cycle for that industrial market will more than 10 years. That would be a good business for TransSiP. And then the next thing is the TransSiP PI 2.0 for turbocharging our business model in a faster and bigger scale. I would like to add more comment about the switching mode power supply. The data we just present on the 5G clock quality was from a switching mode power supply. But the ideal case was based on a linear regulator. So the right high-end signal analyzer, they provide a very clean power source that was based on linear regulation. But in real world, basically all of them are just like linear switching mode power supply, like the PMIC, the power management IC. They are very noisy. So after our filter integrate into that, the performance is equivalent, if not better, to the linear regulator, as being so on as we have observed in the lab setting. So that is the exciting thing. So hope that we answered your question. And interestingly, and also we would like we would also want to ask our investor to help us to spread our message, because we observe one thing. Although we are the first and the only one to put our business on equity crowdfunding, but we also see a problem. Not many people understand what this business is. Recently, I looked at a report published by DeLorme. DeLorme is one of the world's big 3 accounting firm. For the past 4 or 5 years, the VC money pumped in the semiconductor business will skyrocket. But however, most of them not happen in the US, even VC. Most of them went to the Asia. Just very few invest in semiconductor startup locally here in America. And then we look at the data for crowdfunding, because I guess we are the only one. We are the first and the only one. We are breaking the ground zero right now, but we need your help. Because not many people understand what's the potential of semiconductor business, but we do. And also VC do. VC all understand how attractive this market is, but they are not investing in American company. That's the problem. Just like the government, the US government, they have not invested in semicon for the last 20 years. That's why we seriously lag behind. We just start to try to get it back. So we would like to our investors to understand this fact as well. So that is very crucial for American as well.
Okay, well, we're just about at the end of the hour. If any other comments or closing remarks, I would really like to thank everyone for their attendance. We're going to have more of these, so there'll be more opportunities for Q&A as we go forward and are developing new angles on the technology.
Thank you.
All right.
Okay.
Thank you very much.
All righty. All right.
Bye.
Thanks a lot then. Bye-bye now.